Hello, everyone, and welcome to Vue.js Live 2024. I'm Evan Yu, the creator of Vue and Vite. Today, I'm super excited to share with you a 10 years retrospective on Vue.js. Yes, you heard that right. Vue is already 10 years old. Sounds like a very long time in front-end world, but and of course, Vue is no longer a new technology, but in this talk, we'll see some of the history of it, and we'll also see what we're doing to Vue to keep it alive and well. Okay, let's dive right into it. So first of all, views today in some numbers. Here are some stats of combined Vue.js/Vue and Vue.js/Core combined stats on GitHub. We have today over 9,326 commits across the two repositories. We have released over 493 versions of Vue. We have over 2 million users worldwide, 250,000 GitHub stars, 4.9 million weekly NPM downloads, and over 1 billion monthly CDN requests on JS Deliver. And we also want to talk about some of the technical impact of Vue, because despite using it day to day, maybe a lot of new users today aren't as familiar with the history of it and what ideas first came out of Vue and what ideas kind of influenced other technologies, right? So back in 2014, Vue was the first JavaScript framework to do deep tracking-based reactivity. Now, tracking-based reactivity is a paradigm that dates all the way back to Knockout.js and Meteor Tracker. That's even older technology than Vue. But Vue was the first one to apply this principle into deep objects. So you can have an object, mutate it, and things just work. And Vue was the first framework to do that. Vue was also the first framework to combine the idea of single file components with build tools. The idea of single file components isn't necessarily new. There was, in fact, an internal project at Google when I was working there was a source of inspiration. But Vue was the first one to combine this idea with a build tool called Browserify back then. And later on, we also supported Webpack. But the ability of single file components with build tools, the uniqueness of that is that we can use additional languages in these script blocks or template or style blocks. So you can use CoffeeScript back then. Today, you can mostly use TypeScript. You can use Sass, Last preprocessors. You can use PostCSS to process your CSS, and you can even use Pug, which was called Jade back then. Different template syntax with your templates. So this was Vue was the first framework to support this kind of usage. And Composition API was the first to combine signal-style reactivity, which is also the tracking-based reactivity that we talked about earlier, with modern component models, right? So you can use Vue refs in a script setup syntax with modern component models. And Vue was the first to actually combine that model into the modern component model that we are all familiar with today. And Vue was also the first to explore a compiler-powered reactivity sugar for signals in the form of the reactivity transform, or which was a experimental proposal that we ran with for a period of time, but in the end, we decided that it was not the best direction for Vue. However, we are actually pretty happy to see that this direction is being picked up by other frameworks, for example, Svelte 5, that actually is also exploring this direction. So it might be a better fit for Svelte, but we believe Vue is in a pretty good place with its own paradigm. Now, Vue is also unique in supporting both template and virtual DOM render functions. This affords a very good balance that offers familiarity for users who prefer the template syntax and a smoother developer experience for people who prefer HTML-style templates. But at the same time, in advanced use cases and for library authors, you can still skip the template layer and drop down into manually writing render functions. That gives you a lot of more flexibility in doing advanced features. And finally, Vue pioneered the concept of the progressive framework, the idea of a framework that is not monolithic, the idea that a framework can be made up of individual pieces, but with a coherent design that you can adopt and use incrementally based on how much you need from the framework. I believe Vue is the first one to pioneer this idea, and is also the only one that has implemented it really well. Now, looking back, here's a brief timeline of what Vue did. Right, we did the first release with the name Vue.js in 2013. That was the first time the name Vue.js ever appeared. But the public announcement was in February 2014. So it remained as a side project for me for a very long time. And it took quite some time for me to polish it enough to feel comfortable, to feel confident to share it with the world. Now, in October 2015, we reached 1.0. I actually took a long break in order to push it towards 1.0. And after 1.0, the template syntax was largely set. And in 2.0, we did the major rewrite, which re-implemented the rendering to use virtual DOM, and was released in October 2016. 2016 was also the year that I started working on Vue full-time. Now, the work on Vue 3 actually started in September 2018. That was a very long time ago. But 3.0 took much longer than expected because of the scale of changes and the scale of impact on the ecosystem it created. Vue 2 was already very widely used, and the work on 3.0 was a learning process for us. There were definitely ups and downs, mistakes that were made, and lessons learned. So 3.0 was soft launched in September 2020 and eventually became the default version in January 2022. So the whole process took a few years, but we are really happy that the ecosystem has finally embraced Vue 3, and we'll see some stats later. So Vue 2 has officially reached end of life in December 2023, and we really encourage users who are still on Vue 2 to consider upgrading, or you should seek out relevant support to keep your Vue 2 versions running. Now, so this was a really kind of like a nostalgic moment where I still have this blog post up somewhere talking about the first week of launching Vue.js. And I was really happy that I got a few hundred GitHub stars in the first week, which was a great achievement for me back then. But after the initial launch, right, there were ups and downs where the reality hits. So I don't know if anyone have heard of the technology adoption cycle. There is, whenever a new technology comes out, there is a technology trigger. There's a peak of inflated expectations. Then there's the trial of disillusionment, slope of enlightenment, and finally you reach the plateau of productivity. Now, I would say there is a very similar process when you get into open source over time. Now, when you first get into open source, there's this great excitement, peak of excitement and output. I was working almost all day, every day on Vue when I was pushing for the initial launch, and also pushing for 1.0, pushing for 2.0. Those were the moments where I could just work on it all day. But there are also moments of burnout and self-doubt when there are bugs, issues, people criticizing the design decisions that we made. And I had to adjust to these comments over time. I had to learn what are the actual right decisions. It takes a really long time for you to realize you can't really please anyone, and sometimes you just have to make hard calls. And eventually we reach the slope of rebalancing and reach the plateau of productivity. But obviously, there are challenges when you need to get through those burnout periods, and that's what I call the chasm. For a lot of open source maintainers, crossing this chasm is the major challenge that you have to go through. And if you're working on open source projects, there will definitely be moments like this. And just know that you have to learn to adjust how to deal with this, and you need to learn to find a balance between your goals, your life, your work, and open source. And I really hope that everyone working in open source can find that, can get out of the chasm and reach this balanced plateau of productivity. So here are some graphs. If you look at my GitHub contribution graphs, you will see that there were definitely moments of burnouts and self-doubts. So I want to be really open about this. I want to let everyone know that even behind some of the most successful open source projects, maintainers are human too, right? So there will time where they need to adjust. There are times where they need to take a break. They will need to find inspiration, they need to go and recharge and find their motivation again. So this happens, this is normal, and I want to normalize this for open source maintainers so that we feel less pressured. And I hope to see few fellow maintainers burn out. And it wouldn't have been possible to carry through without the support from the amazing Vue community. So I'm putting the word up here 3 times because that's how important it is. If I were Steve Ball, sorry, cut this part out. Okay, thank you. I'm putting the word up here 3 times because that's just how important it is. The Vue community is the one single thing that I'm the most proud of. Vue is about people. It's the most diverse, inclusive, welcoming, and open-minded community that I know of, full of amazing and wonderful people. Without the community, I would never have had the energy and persistence to keep working on Vue and push through those chasms or burnout periods. So Vue wouldn't be where it is today without you all. So here's my deepest gratitude to our team members, to the contributors, to the ecosystem library maintainers, to the community partners, conference and meetup organizers, Vue advocates, and sponsors. Okay, so now let's talk a bit about sustainability and independence, which I think is also another aspect that really makes Vue unique. Vue is currently the only mainstream framework that remains independent, i.e. not dominantly owned backed by a single corporation. Why is this important, you may ask? The reason, I think, is we are not constrained by the financial support of a single entity, which means we're not going to be swayed in the technical directions just because one big backer wants us to go a certain way, right? All of our sponsors, all of our financial supporters are decentralized, and they don't really have strong swaying power into the technical decisions made for the project. So the project is able to operate solely considering the interests of the users. And every user's opinion will get equal consideration. And another important aspect of the Vue ecosystem is the collaborative mindset. Thanks to the independence, right? The Vue ecosystem is unique in a way it spawns many, many notable efforts that end up benefiting more than the framework itself, right? If things were for benefits, this would look quite different. The Vue community has been the source of multiple efforts that benefited the entire JavaScript ecosystem as a whole. Just to name a few, we have Vite, we have Volar, we have Vue.js, Nitro, and some cross-framework dev tools work that's being worked on. All of these from Vue and Vite community members. And finally, I want to take a peek into the current state and the future of Vue. So, Vue 3 usage has increased by 77.6% over the past year. Very strong growth for Vue 3, and it's also taking up a much larger percentage of total Vue downloads, and now constitutes over 58.3% total NPM usage. A lot of legacy Vue 2 applications are obviously still running, and people will still continue to work on it. So it's still good to see the percentage of Vue 3 continues to grow over time. Now, 3.4 is the current minor release, which was released in December 2023. The main flagship feature in 3.4 was a completely rewritten parser that is 2 times faster than before. So one thing I want to really emphasize is even if Vue is a 10-year-old framework and Vue 3 itself is almost 6 years old, the code base is 6 years old, we are still finding lots of room of improvements here and there. And we are always going to keep digging into these opportunities and finding performance gains and experience improvements for our users. Now, 3.4 also shipped a more efficient reactivity system that reduced a lot of unnecessary calculations in computed properties. We also stabilized defined model and shipped vbind same name shorthand, both of which have great developer experience improvements. Now, the most recent notable change in 3.4 is in the recent patch, we shipped some pretty important server-side rendering performance improvements. Now, this was largely triggered by a public benchmark that has been circulating around on Twitter. And by inspecting the benchmark, I was able to identify a few cases where some of the optimization was leading to Vue's poor performance in the original benchmark. So now with those changes landed in 3.4.22, we see a whopping 3.8x improvement in that benchmark for Vue alone. And for Next, there's also a very, very notable 1.77x improvement. And Daniel has also submitted a pull request that optimized the Next usage when using async data that avoids using deep data structures for fetching the data, which is going to be the default in Next 4, which again improves the performance in that benchmark by quite a bit. So if you're using Next or you're using server-side rendering with Vue, your other methods, make sure to upgrade to the latest version. So let's talk a bit about what's planned for the next version in 3.5 and beyond. So first of all, we're shipping even more reactivity efficiency improvements. So the current minor branch on GitHub is the in-development branch for 3.5 has already merged two very important pull requests for the reactivity system. PR number 10407 provides a rewrite of the reactivity system again. So the internal tracking data structure has been refactored with a 56% memory usage improvement. So memory usage is quite important because in data-intensive applications, garbage collection can actually be a performance killer. So using less memory is going to help a lot for highly dynamic applications. Now, 9511 provides a 10 times gain when tracking large reactive arrays. Now, this has been actually quite a common source of performance bottleneck when you have really, really large arrays and you put it into a deep data structure. Now, this PR actually provides a smarter way to avoid tracking unnecessary dependencies when iterating through over these large arrays. Now, and provides very, very significant gains in these cases. We are also thinking about stabilizing reactive props to structure because we're seeing quite positive feedback in the RFC discussion. But before we finally do that, we would encourage you to voice your opinion in the RFC to help us make a final decision. There are also planned SSR improvements in 2.5, but the primary one being to stabilize suspense. It has been experimental for a very long time, and we're really looking forward to stabilize it. And then there are small APIs like UseID, quality of life improvements like built-in HTML nesting validity check, helping you to catch cases where you are accidentally putting divs inside Ps or Ps inside divs. And we're also going to look at a possibility of built-in lazy hydration using async components as boundaries. Now, a lot of you are probably curious about the status of Vapor Mode. Now, we are making great progress on Vapor Mode. So it can already run to do MVC in case you don't know. So you can try it out in the playground already. So there, if you download the slides later, you should be able to find the link and try it out. Or you can go to the core Vapor repository on GitHub and see it. You should be able to find the link there. The current stage focus for Vapor Mode is component implementation. And the good news is we're almost there. So if you look into the linked issue here, we've covered a lot of the parts for components, and there are only a few things left. And once we finish components, the next stage focus will be on the interop between Vapor and Virtual DOM, i.e. being able to compile and embed Vapor components into your current applications. So that's going to be the next big milestones to hit. Vapor Mode is a team effort. It is being led by Kevin, and we have a lot of great contributors helping with Vapor, which is really exciting to see because this is a pretty advanced implementation, and I was happy to see that by setting the initial direction, a lot of community members are stepping up to help us work on Vapor in parallel to current Vue core work. And finally, we want more development experience. So some of the work I've been doing outside of Vue is further improving Vite by investing in lower level toolchains. So a lot of you may know that we've started a new Rust-based bundler called Rowdown, which is intended to support Vite in the future. Rowdown is now open source, and we're seeing great performance. And we currently have finished basic bundling, basic chunk splitting, and source map support. And with all these implemented, we're able to run some benchmarks, and we're currently being 1.5 to 2 times faster than ES Build, which is super impressive. And we are also contributing to OXC, which is the lower level language toolchain, Rust-based parser for JavaScript that we're using inside Rowdown. And we're having a very tight collaboration relationship with the OXC team. And we also have team members working on extracting reusable layers between Nuxt and Vue dev tools, and potentially use the same kit to support other kind of dev tools in the future. And we also have continued improvements in Volar v2, i.e. Vue language tools. So Volar v2 was shipped with the support for hybrid mode, which allows us to use the single TypeScript language server to support inferring the entire project, both TS and Vue files. Now, this is very, very efficient memory-wise, performance-wise, but there are a lot of edge cases, and there are still some rough edges we need to stabilize. But we're seeing really, really great promise in the performance of this direction. Okay, and finally, native signals. This is something I want to talk about a bit extra. In case you don't know, there is a TC39 proposal to add signals as a native JavaScript language feature, and is now stage 1. Signals, if you are not familiar with the term, are reactivity primitives similar to Vue refs. So if you've used Vue refs, you've used signals. The Vue team has been involved in the discussion of the proposal from the very beginning, and we're experimenting with the possibility of a native signal-powered version of @Vue/reactivity, the lower-level reactivity engine that's powering Vue proper. By using native signals, we should be able to get less code to maintain and bundle. So less code to maintain in the Vue code base, less code to ship to the end users. And there should be better performance and memory consumption because native signals can be implemented in native languages. And there is the potential for cross-framework interop. Think cross-framework Vue use. If we can use Vue use across multiple frameworks, that would be a dream, right? So we're looking forward to this happening in the future, and we're working with other participants in the proposal to make sure that we reach a very interoperable implementation when it actually lands. So that is all for today, but we are far from done. So Vue is 10 years old, but there's just still so much to be done. We experienced a period of fragmentation during the Vue 2 to 3 transition, but now that Vue 2 is officially end of life, the Vue 3 ecosystem is thriving with higher quality utilities, component libraries, custom renderers, and meta frameworks than ever before. And we're here to support more of this in the coming years. We've survived through the JavaScript hype cycles. Vue is here to help you get your job done, not to sell you pay service. We're proud to say we stay true to that statement. We may not be the most trendy solution nowadays, but we're here to stay, and we'll always be consistently improving, one thing at a time. Thank you.